if you show up without your note card to take the test that we will be taking next week, then you're out of luck. Okay. All right. Okay, so here are what the problems are going to look like. Okay, so our book uses this notation instead of, guys, quiet. All right, our book uses arc sign instead of sine inverse, but they are equivalent. So, yeah, it's arc tangent, arc secant, arc cosine. So, I feel like you're more likely to see the inverse notation, but
just in case.
But you might see this. So, the formula for inverse sine, the derivative of inverse sine of u was, you just wrote this on your card so you don't necessarily have to recopy it again. It was u prime over 1 minus u squared, right? I don't have these memorized that well either. So, in this case, what is our u? The 2x, right? So if we're taking the derivative of this, we're going to use this formula. And in the numerator, we're going to have u prime. That's just the derivative of 2x, which is 2. And then the bottom, we'll have 1 minus 2x squared. So this is going to end up being 2 over the square root of 1 minus 4x squared. Square the 2 and the x when you square that. This is it.
Why is it not 2x on the top?
You take it's a u prime, so you take the derivative of whatever your u is.
I have a feeling we're going to use a chain rule with this. What do you think that one might be?
Okay. Questions? Okay, this time we have arc tangents, and we're supposed to find f prime of x this time. So we're still doing the same thing as the last problem, except we have tangent. So that tangent formula, the derivative of inverse tangent, actually it was the inverse tangent or arc tangent of u. That formula is u prime over, is it 1 plus?
Yeah, 1 plus
U squared. Okay, what's u for this one? Or u right here. So for this one, f prime of x is going to be u prime on the top, which is 3. On the bottom, 1 plus 3x squared, which ends up being 3 over 1 plus 9x squared. U just stands for whatever is inside of the parentheses for your arctangent. With the note card, they're not that terrible because you were basically just using the formula to help you fill it in. What makes these so hard is, number one, whenever we get to integrals, they're hard to recognize you even need arctangent, and then having the formulas memorized because it's just they're a little bit complicated formulas. Yeah, they're very similar. Yeah, but with the note card, they're not too awful bad. All right, copy this one down. I want you to have this one in your notes so you can look back at it. There's some up here, Daniel. Or there should be, except for you guys that are using up all my paper quick. I'm probably going to run out soon. It's not, but might be nice if you're one of those who has been taking advantage of the paper welfare system up here.
Oh, wait a minute.
Now, this problem looks really terrible. But this right here, I mostly put this here for us to remember a little bit here. You almost never are going to have to actually do like a limit. You never have to do a limit definition of derivative again, really. You just have to recognize the limit definition of a derivative. G minus g of square root of 3 over x minus square root of 3. This is limit definition of a derivative. Okay? This is limit as x approaches a of f of x minus f of a all over x minus a. Right? This is limit definition of derivative. This finds f prime of a. Right. I don't have that yet, but
Jack, what?
root 3 over 2. Sine. Did you take the derivative? Did you take the derivative? Okay, so no. Sine inverse of square root of 3 over 2 would be 60 degrees. But this was looking for the derivative here. So what this is wanting to find, g is the function. What number have they plugged in where the a is at? That square root of 3, right? Right? So where that a is at. So what this is really just asking you to find is g prime of the square root of 3. So you have to find the derivative, the g prime of x, first. So, what is our formula, or say our formula for sine inverse of x? No. This is inverse, that should be a u. U prime over square root of 1 minus u squared, right? What is our u? X over 2. That's our u. So what's u prime? One half. Because x over 2 is the same as 1/2 x. Okay, so the derivative of 1/2 x is just 1/2. And then in the denominator, we got 1 minus x over 2 squared. So we got 1/2 over the square root of 1 minus x squared over 4. Well, the question wanted us to find g prime of square root of 3. So we got to plug in square root of 3 here for our x. So g prime of square root of 3 is going to be 1/2 over the square root of 1 minus square root of 3 squared over 4. And so, like, for your response, you could stop here, but, you know, if this shows up on a multiple choice, that's not going to be an option. Noah, put this phone up here on my desk for me. That's going to be, 3/4. So that's 1/2 over the square root of 1/4, which is 1/2 over 1/2, which equals 1. Just think, take the square root of the top, square root of the bottom. So the square root of 1 is 1, square root of 4 is 2. Yeah. No. They are not. Daniel, you want your phone to come up here and keep Noah's company?
You can take it, bro. I don't use it. I just changed the song.
Alright, questions? Alright. Okay, so here is some implicitly defined functions. I think that's going to make things worse if we do that. You could, but then you got to take the derivative of e raised to the arc cosine of 3x, which means you got to use a chain rule with your e, and I don't think it's going to be the easiest to do, but you could do it that way. So, this is implicit. So, on the left side, you just take the derivative of arc cosine of 3x. Oh, cosine's the one I never remember. What's that formula for cosine? I don't think... What is it? Oh, it's just the negative sign. Okay, yeah. Okay. Okay. All right, so we got negative 3 over the square root of 1 minus 3x squared. On the right-hand side, what is the derivative of natural log of y? 1 over y times dy dx. Alright, so when you take the derivative of anything with a y, you just have to put a dy dx. Alright, we want to get dy dx. We want to solve for dy dx. So how could I get rid of this 1 over y? Times y. If I multiply by y here, it just cancels. Multiply by y over here. It's like y over 1. So I would have negative 3y over the square root of 1 minus, I'm going to write that as 9x squared, equal dy. Yeah, 1 over y is the same as something being divided by y. Or you could think of writing it like this. It would be dy over dx over y. When you're multiplying both sides by y, you're multiplying by y in the numerator of both sides. So, like if this is in the numerator, then these y's right here cancel, and you just have that dy dx. Yeah. Okay, questions? Okay, here's a fun one. There's two ways to do this, I might need to go.
No, I thought it said that too. I thought T is such a ghost.
Alright, so trying to decide. Can't find this one. I know a couple ways to do it. I'm trying to decide which one's best. But okay, we'll just. Okay, so we can use our cotangent formula. Cotangent is going to be negative u prime over 1 plus u squared. So in this case, our u is cosine of t. So what is the derivative of cosine t? Negative sine t over 1 plus cosine squared t. Oh, let's see. We should have a positive because it's going to be the derivative of cosine is negative sine, but the cotangent formula has a negative out front. Yeah.
How do we get cosine squared t? Oh,
I just put the square here instead of on the outside. The question is, and I wish I could find this problem to see if they leave it like that. Let me just see real quick what the calculator does with this, because I can't. Yeah, it's 1 minus. We could definitely change, which we don't have here. Let's see. All right, let me do this. Let's just see real quick what the calculator. Cotangent does not have a square root. So if we're differentiating. Oh, there's no cotangent inverse.
What?
I don't think that's right there. Okay. Try this next one right here on your own, while I try to decide.
No.
I'm not sure if you can simplify it further, and I'm going to try a different way. Oh. I don't think so, because this u prime covers that. That was kind of like your chain rule involved. Yeah. So, sorry. I was looking. Okay. All right. Do you need to do product rule?
Oh, yeah, you do.
For that second part,
I just saw the adding sign. I was like, is that a -2 after the x?
minus 1 minus x squared here.
Is that a -2 or is that just
It's just a regular 2. Alright, I want everybody trying this one on their own. I'm going to freeze this so I can work this one out. Yes. Yes. So, yes, so the derivative on top will just be a 1. Good. 1. Because you're taking the derivative of that x, so the derivative of the x will be a 1. I do think we should get some t-shirts. My AP Calculus training guy, his class they had all kinds of like calculus merch. So. A lot. Yeah. Past the third row.
Like denominators a lot?
Yes. If you even did denominators, if you did product rule, you might not have denominators. If you don't send stuff back down to the denominator, you might not. You will eventually have a denominator, but in your final answer. But. Take it back. You will not have a denominator in your answer. This is crazy. I feel like I need to check this with the calculator and make sure.
I'm so confused.
There's some massive simplification that goes on here.
I got 1 over square root of 2 plus 1 times. Dude, I got like 30 axes. I'm gonna have no idea what you put up for. Yeah, that makes sense. You know what? I think I love it. See, what she does, I would think of by myself. Mine's using the calculator. That's not even fair.
I'm just double checking. Because apparently I didn't print off these notes last time I did them, and I don't have the answers.
You're telling me there's no denominator?
I don't know, maybe messed up. You might have a denominator. Let me see what this is.
I got an answer, but I don't know why you did. I got negative 4x squared plus 2 over 1.
You want to use Desmos 2 to double check me. I think I've got the same thing as the calculator, but I can't tell.
1 minus 0 is 0, and 0 in the denominator is 0. So arc sin x equals 0.
That is incorrect.
To go.
Who are y'all talking about? Okay, yeah. The calculator doesn't simplify it as far as I did, but I'm pretty sure that this is the same. You may still be correct, but it'll simplify pretty far. Okay. Okay.
Oh, I was nowhere.
2 times the square root of 1 minus x squared. Alright, so, up here, arc sine is just the formula, right? 1 over square root of 1 minus x squared. Over here, product rule. I just did, but you weren't paying attention. Alright, so here is the route I took. Because you have all of these 1 minus x squared, you got one right here, and one right here. I changed everything so it was exponents like this. And then I took and factored out the 1 minus x squared to the negative 1/2. I factored that out. So it's like I'm dividing 1 minus x squared to the negative 1/2 for all of these. Yes.
Okay, so in the first blue line, you've got after the plus sign, you have x times 1 half. How did you go from that to negative x?
This negative 2x over here on the end. Yeah, if you forgot that, that has to be your chain rule. Because you do x times 1/2, 1 minus x squared to the negative 1/2, times the derivative of the inside, which is negative 2x.
I didn't factor anything out. I got the right answer.
So these cancel and just give you a 1. These cancel and you just have the x squared. This is going to move to the top and be 1 minus x squared to the first power. And then here we just simplify by combining. Move this right here back down to the denominator. At this point, it feels like you should be able to stop. But you could factor out a 2, which means that you got 1 minus x squared on top and bottom again. So this is 1 minus x squared to the first power, and this is 1 minus x squared to the negative 1/2. I'm sorry, that shouldn't have a negative right there. It should be a positive 1/2. Doesn't affect my answer. I just wrote that wrong. Positive 1/2. And so 1 minus 1/2 is going to give you 2 times 1 minus x squared to the 1/2, which is 2 times the square root of 1 minus x squared.
I kept the x with a heart. I'm joking.
In the numerator?
Yeah.
Yeah, derivative of that x is going to be 1.
Wait, how did you simplify it to 2 root 1 minus 1?
So because these two right here match, you can just subtract their exponents, which would give you, I didn't write it, but it'd be 2, 1 minus x squared to the 1/2. Whenever you do 1 minus 1/2, and that you can write as the square root. You're talking about the simplifying part, Laura? Or the taking the
I
derivative?
just don't know how to start, and then I'm fine, like, what to, like, if someone just told me, like, oh, you have to, like, have X amount of numbers, and then just go.
Are you alright taking that very first step where you take the derivative, though?
Yeah.
Okay, so it's
It's just
what to do to simplify. Yeah, that's one thing to look for is if you have like an expression that's showing up over and over again, like the 1 minus x squared here, it usually can be factored out somehow. So that's one thing to look for.
I can do simplification. I just can't start. Yeah, literally. I don't know. I can, like, do the pull out with the 1 minus X.
So like right here, can you get this?
Yeah, that's cool.
Yeah. Anything separated out by plus or minus signs, you're taking the derivative of those things separately, Laura. So like that arc sign is going to be separate from the stuff behind it. And then, right, and then so the other stuff over here, you might have to use product rule, you might have to use chain rule. If you have two expressions with x's in them, you got to use the product rule. And then a lot of times if there's exponents, you're going to have to also use the chain rule inside of that. Yes?
I don't understand the very last part.
Going
You
from,
bring up the negative, the 1/2, you brought that up from 1.
yes, and made it negative.
But wouldn't that be just what 2 times 1 minus X squared?
So like, if you move this up to the top, you're going to combine those exponents. So it'll be a 1 and a negative 1/2, which 1 minus 1/2 is going to give you 1/2. Okay, questions? Okay, the hard part of that is not the inverse trig. The hard part is the older stuff, right? And the simplifying. The inverse trig was a pretty simple step of this. Yeah. But once you did the inverse trig, it's all the other stuff that's really difficult. So it's not so much that the new stuff is making that difficult, it's just all of the simplification is pretty tough. Okay, we are not going to do the assignment from the book today.